Welcome to Module 3, Economic Models, where you'll learn about the PPC, which stands for Production Possibilities Curve. Sometimes this model is shortened to PPF for Production Possibilities Frontier, but it's the same thing. This is a model that's going to show us all kinds of economic concepts like trade-offs, scarcity, unemployment, efficiency, and economic growth. The major idea behind a PPC is that we have to assume that an economy can only produce two goods. So in the PPC below, this economy could either produce robots or pizzas. At this point here on the curve, if we're producing at that point, then we are making 10 robots, the maximum amount of robots possible. But if we're putting all of our resources towards making robots, then we're not making any pizzas. This point would be 0. If we are instead producing on this point of the curve, we're focusing only on pizzas and making 200 pizzas and 0 robots. So it is not possible to make the maximum of both. You can't make 10 robots and at the same time make 200 pizzas. We're going to assume that we're looking at it in a limited amount of time with limited resources because remember, there's scarcity in the real world. So in order to make more robots, you're giving up the ability to produce pizza. And that is this trade-off, that if you're making more of one, you're going to make less of the other good. That any choice, remember, has an opportunity cost. Next, we're going to talk about a lot of the different economic concepts that the PPC shows. This is going to seem fast at the beginning, but don't worry, we're going to practice each of these skills. So, on this PPC, remember this is the same one before where we can either produce at maximum 10 robots, and if we're doing that, then we're not making any pizzas at all, or 200 pizzas and therefore 0 robots. But we can also produce anywhere that is on or inside the curve. So here at point B, that's on the PPC, that is on our production possibilities, which means it is possible to produce that much. At that point, you can tell we're producing mostly robots, but some pizzas. At point C, we're producing mostly pizzas, but some robots at all. Both of those points are possible. Point A is making less than what's possible. So this entire curved line is the production possibilities. If we're making anything inside of it, then we're actually making less than what's possible. So that is this part in green. A point inside is attainable but not desirable. So, is it possible to make less than your maximum? Yes, but it's not good. A point outside, point D here, is desirable. We would love to make more than what's currently possible, but it's not attainable yet. We're going to learn what needs to happen for that to occur. Now back up to the top, these economic concepts that this model shows. The first one is scarcity. There's only so many resources, those factors of production. We only have so much time, so many workers, and we only have a limited amount of the resources that we use to produce robots or pizzas. That's why at maximum we can only make 10 robots or 200 pizzas. There's not an unlimited amount because our resources are scarce. Next, if we decide to move from this point here to point B, that's an option. It is still an attainable point. It is possible, but we're deciding to make fewer robots and therefore more pizzas. Maybe our people are hungry and we need that. Now, there are trade-offs to that decision. So if you decide to produce more pizzas, then what you're giving up is the ability to have as many robots. Those are your trade-offs. Now, the exact number of robots you give up, that will be the opportunity cost. And we're going to find out how to do the math to determine the exact number of the other good that you're losing when you make that choice. The next term here, economic growth, that is this point D. So it is going to be possible for the entire PPC to shift outward. Maybe we develop better technology to make both goods. Maybe we have more workers. There's going to be various things that will happen that will help us produce more goods in the future. If the entire line shifts outward to the right, we reach growth. So this point D is only possible with growth. Any point on the line is efficient. We're using our resources to the best of their ability. So in this case, B is efficient, C is efficient, A is inefficient or not efficient because it's not using resources fully, and D is impossible. Now for unemployment, think about where on the model are we actually not using all of our resources. Remember, labor is a resource. So at point A, anything inside the curve, you don't have everyone working, and therefore you're not able to produce the maximum of any product. So any point inside the curve is possible, but because you're not being efficient, you're going to have high unemployment. You're not using your labor resource wisely. Again, we're going to practice all of these things, but it's very important to understand this slide and how all of those vocabulary words are shown on this same model. Anytime you're learning about a macroeconomic model, we have to make key assumptions. We're going to assume certain things to be true, and this helps us to really simplify models in order to learn something from them. The first assumption for PPCs is that only two goods can be produced. Now, obviously, in any economy, you can make more than two things. There's no country in the world that's only making robots or pizzas. But the point of this simplification is we can see how if you're choosing to focus your resources on one thing, then you're taking them from something else. And that's true with unlimited numbers of products. Also, we're going to learn later that you can do PPCs with categories of goods. So you can focus production on capital goods. These are tools and machinery in the economy. Or you can focus production on consumer goods, things like food, clothes, entertainment. So the idea is if you simplify it to two individual goods or two categories of goods, this really helps us to see trade-offs and opportunity costs when you move between. The next assumption is that resources are fixed and employment is full. The resources are fixed means that we're not going to all of a sudden tomorrow find this giant supply of iron with which we could make more robots. That would change the economy. And remember, ceteris paribus, all other things equal. This is an economic law that we don't try to add variables and change things as we're going. Now, it's possible that years from now, there might be more materials that we could use. So that's why, number 3, production is for a specific period of time. You have to limit, are we making this many in a day or in a year? So the Italy's PPC there, the assumption is that they're making either 10 robots in a day or 200 pizzas in one day. We have to narrow it to a certain window of time so that you can compare one country, Italy in this case, to another country to see what they can produce. We're going to start comparing countries to figure out trade later with PPCs. The last part of number 2, employment is full. That's telling us that if you're any point on the PPC curve itself, that you have full employment. So in this case, points B and C, employment is full. That means everyone who is able to work and wants to work is working. Remember, A, any point under the curve, is high unemployment. And then the last assumption, technology is fixed. If all of a sudden we invent a new assembly line technique, maybe we can make more of both goods. But again, that changes things too much. So as long as we're looking at these goods in this window of time with our current amounts of resources, employment, and technology, then the PPC works. Try not to keep thinking, what if this, what if that? Too many what ifs muddle what you're studying, so we're focusing on only these things at hand. The next thing to learn how to do is to create your own PPC from a table. So here you have a table of two goods, bikes and computers, and it gives you a list of numbers and points that they correspond with. So you can see that at point A, we have 14 bikes and 0 computers. So normally you could draw bikes on this axis and computers on the x-axis, or the other way around. It doesn't really matter which way you set it up. But in this case, the question does tell you to put bikes on the y-axis and computers on the x-axis. So go ahead and do what the question tells you to do. So you're going to label bikes on this side, and you can do it, I recommend doing it towards the end, bikes here, computers towards the end of the other one, just so it doesn't get in the way of your numbers. Or you can do it just towards the bottom, as long as you leave space for the numbers. You also want to start drawing in the numbers. From the table, you can see that bikes need to go up to a maximum of 14. So the highest point on the bikes axis should be 14, and the highest point on computers should be 8. When you're writing the numbers, you want to make sure that you're evenly spacing them. So 0, 2, 4, 6, 8, those should be equally spaced hash marks on your line. And then the other side should also be equally spaced, 2, 4, 6, 8, just so it's all very symmetrical. So this is what it would look like when you have the axes labeled and numbers in place. Computers didn't need to go up to 10, but you can put it all the way up to 14 if you want for it to be symmetrical, as long as you've hit both of your maximums in the table, so 14 bikes and 8 computers. Once you have the axes labeled and the numbers labeled, you can start plotting the points. So point A, you're going to find where bikes are 14, where computers are 0. Go ahead and draw a dot and label that point A. For B, you're going to go down to 12 bikes, over to 2 computers, draw a point, label it B. So on and so forth. When those are all plotted, it should look like this. So your point C is 9 bikes and 4 computers and onward. Every single point plotted. Once you've plotted each point and labeled it, because it tells you this is point C, this is point D, so label it appropriately, then you're going to connect all of the dots. Make one line. In this case, the line is a little bit curved, and that's important. This is why you wanted to make sure that you're evenly spacing the numbers. Later you'll find out that some PPCs have straight lines and some of them are curved, and that will tell you a little bit about the PPC itself. So that's how you draw your own PPC from a table. Take a moment before we go too much further and add some new information, and just make sure that you understand how a PPC demonstrates scarcity, opportunity cost, economic growth, efficiency, and unemployment. Make sure that you're confident in which point on the model show each of these concepts. If you're not 100% solid on this yet, we're going to review this one more time at the end of this module. Next, we're going to learn about the two major types of opportunity costs that we can see on a PPC. Remember, opportunity cost is the best thing that you're giving up because of the choice that you're making. And PPCs, we're making a choice. Are we going to produce this good or the other good? Some types of goods, some categories of goods have constant opportunity costs. So when you're filling in your table, you want to make sure and say the characteristics are that these goods are easily adaptable. What that means is that it's easy to switch from making one good to another. I'll tell you one example, but don't put this one in your notes. Go ahead and think of another example. So one example of two goods that are easily adaptable, we have here pizza and calzones. If calzones are things you're not familiar with, they're kind of like a pizza. It has pizza crust on the outside and cheese, sauce, toppings on the inside. So if you are a producer and you're producing pizzas and all of a sudden someone asks you to make a calzone, that's not too hard to switch. You can easily switch one worker to start producing calzones, and you already have all of the resources that you need on hand. It's a very easy thing to go back and forth. You can easily adapt from making one to another, and that's what makes it a constant opportunity cost. Think of two other products that you can easily switch from making. We're going to do some other ones throughout the notes today. So this could be if you're cooking example, you could switch from cakes to cupcakes. If you are farming in the same field, you could maybe switch from tomatoes to peppers. You want to think of goods that are not going to be difficult. In your factory, you could produce jeans or shorts. It's not going to be horribly challenging to move back and forth. When you're drawing a PPC with constant opportunity cost, it's very important that it is a straight line. For your notes, you don't need to draw the numbers, but make sure that you have two goods labeled that are similar on your axes, and that the line is very straight. That's important. The next type is increasing opportunity cost. The idea here is that not every type of good is easily adaptable. So here you have our example before, pizzas and robots. If someone came into your pizza shop and asked you to build them a robot, that would be very difficult. You probably don't have trained workers on hand that know how to make robots, and you also don't have the other resources, the machinery that you would need, the raw materials that you would need to make it. So it's going to be difficult. It's going to slow you down, not be very efficient. So you're going to have increasing opportunity cost. So anytime you're making two goods that are very, very different, and it's hard to jump back and forth making one to making the other, that's going to be an increasing opportunity cost. And that's going to be shown by a curved line. So let's look at the numbers here to see why they're constant or increasing, why the shapes are the way they are. So with the constant one, from the point here to point A, if you decide to make pizzas, you're going to go up 60 pizzas and down 2 calzones. Next point, up 60, down 2. Up 60, down 2. So it's constant. Every single point along the curve is the same. But with the increasing opportunity cost, in order to start producing pizzas, there's a little bit of a different number. So every 3 robots you change, you're giving up more and more and more and more and more pizza. We're going to see other examples later, but other goods that could be increasing opportunity cost would be, before I was talking about jeans and tomatoes. Those are very different things to produce. Maybe origami and computer technology. Just any goods that have very different resources are going to have a curved, a bowed out PPC line. So sometimes you'll be told to draw it either curved or increasing opportunity cost or constant, and other times you're going to plot the points and determine from that would it be increasing or constant. The one that you drew before with the pizza and, I think it was bikes and computers before, that one was curved. So that one would be increasing opportunity cost, not constant, and it makes sense because it's going to be difficult to switch from making bikes to making computers. You need different machines and different tools to do so. Now that you know the difference between increasing opportunity costs and constant opportunity costs in a PPC, let's look at some examples. Here we have 2 examples. In blue, we have a PPC that would show corn and wheat, and in red, we have a PPC that would show cactus and pineapple. So think of which of those 2 combination of goods are going to have a straight line PPC. A straight line shows constant opportunity cost. So which of these things are similar resources that you would easily switch between? And which of these are increasing opportunity cost? It would be difficult to switch between producing one good and another because the resources needed are very different, which would lead to a bowed out PPC. Here comes the answer. Corn and wheat is going to be a straight line. It will be constant because the same field on the same farm could easily grow corn and wheat. They're grown in the same environment, so it would not be difficult to switch in between, therefore a constant opportunity cost. Cactus and pineapples are different because cactus tend to be grown in the desert And pineapples are grown in the tropics, very different climates and different environments. So if you're in the desert growing cactus and you decided to switch to pineapples, you're going to actually need to spend a lot of money and resources changing your soil, trying to change the environment to produce any pineapple at all. That's going to lead to increasing opportunity costs and a bowed out PPC. Now we're going to practice using a PPC to figure out opportunity cost. A little review here. If you're switching from producing all bicycles to producing some computers, there's going to be trade-offs. If you make more computers, the trade-off is there's fewer bicycles. The opportunity cost will tell us the exact number of bicycles. So for each new unit of computers we make, how many bicycles are we now unable to make? So we're going to practice using this picture. Now, what I'm trying to make clear is that an opportunity cost is not just a number. It's a number of the other good. So, for example, if we're moving from A to B, we're gaining computers. Opportunity cost is what we're losing. So, we're losing bicycles, moving from A to B, but how many bicycles? We had 14, now we have 12. So you subtract 14 minus 12, we've given up 2 bicycles. The next one, from point B to D, which good are we gaining? We're gaining computers. So I want you to take a minute and try to see if you can do B to D yourself. Okay, so we're gaining from B to D 4 computers, because we had 2, now we have 6, but we're losing 7 bikes, and let me show you why. We had 12 bicycles, and now we have 5. 12 minus 5 is 7. Now, the other way around, D to B, now which good are we gaining? We're gaining bicycles. So if we're gaining bicycles, the opportunity cost will be in computers. So go ahead and calculate how many computers we give up if we move from D to B. The answer is 4 computers, as we had 6, now we have 2. Now, from F to C, what is the opportunity cost? This one's a little bit trickier. I try to always do kind of a stump you question together. That way, if it's not going to be the first time you see it on a daily quiz. Now, from F to C, we are gaining bicycles. We gain 4 bicycles. But what do you know about point F? F is inefficient. We're not producing fully. We have high unemployment. So in order to gain more bicycles, are we actually giving up any computers? No. We had 4, now we still have 4. So you might think the answer is 0. We gain nothing. We lose nothing. But that isn't technically true. Remember, opportunity cost always needs to include the other good. So just putting 0 or nothing wouldn't be enough. You have to say that we're losing 0 computers in that move, that we do gain bicycles and we lose no computers. And finally, what do we know about point G? We know that point G is unattainable. It is impossible. We can't currently produce at that number unless the economy grows. Most economic models have shifters. Shifters are something that shift or move the curve. In this case, there's 3 shifters for the PPC. The first one is when resources change in either quantity or quality. So for example, if there are more resources needed to produce the goods, then you can produce more of both. So maybe in that case, if it shifts, if you can make more of both, then how you shift it is you draw both of them can be more. So, and then an arrow outward. That would be an increase in quantity or quality. So maybe the materials are better, or maybe you have more of them. Another example of a shifter would be a change in the technology. So maybe there's something that makes you able to produce more robots. So if it only affects one, then you would stay at the same point for pizzas, but you can make more robots. So the line shifts with an arrow showing that you can change more of one and not the other. Now, technology could affect both. So whatever the situation is, think about, can you make more or less of the products? And can you make more or less of both products or just one? And then also change in trade. So perhaps there is a country, a new trade partner that now you have access to more because you're trading with somebody else. So the options for shifts, it can shift outward if there's an increase in both. We saw if only one shifts, but you also can shift inward. Maybe something happened and there's a major decrease in technology. Let's say there's a blackout, or we have an oil shortage and people can't get technology. Then you'd be able to produce less of everything, and both of them would shift inwards. So that's how you draw shifts. Go ahead and with your pencil, read the two scenarios on the two examples below. Try to determine, would it shift robots or pizzas or both, and then want to shift them inward or outward. So go ahead and draw the shifts, and then we'll check over your answers. Now let's go ahead and check your work. So the scenario was that there was an increase in population. So would that affect robots or pizzas or both? And if so, would it make you able to produce more or less of each of those goods? So an increase in population affects both. If you have more people, you can produce both more robots and more pizzas. So both lines shift outward, and you have to have an arrow showing. And you might say, why is the arrow important? Well, if you have just two curves, it's really impossible to tell, did the curve shift in or did it shift out? Where did it start from? So you have to have the arrow there. Another question, just to review a moment. Do you remember what the 4 factors of production are? Those are the 4 types of resources that we learned about in Module 1. So we have land, labor, capital, and entrepreneurship. Which one do you think would be population? That's labor. Okay, so if you have labor increases, that means the quantity of a resource went up. That's why it counts as a shifter. Next example, we had a technological improvement in pizza ovens. So would that affect our ability to produce robots, to produce pizzas, both, neither? That sounds like just pizzas. So if we can produce more pizzas, then the amount of robots would stay the same, but we're now able to produce more pizzas than before. So the pizza part of the line shifts outward with an arrow showing the shift. Now we just reviewed the 4 factors of production: land, labor, capital, and entrepreneurship. Which one would technologically improved pizza ovens fall within? That's a little harder. That's part of capital. Remember, capital are tools and machinery that people can use to produce goods. So pizza ovens themselves are parts of capital. That is the resource that improved in quality, which shifted our PPC. Now that you're getting some practice with shifting, we're going to try some more examples. For the next 3, you're going to start by actually drawing the PPC from scratch. Now I wanted to point out the picture below. Just because the PPCs we've had thus far have been shaded inside, that's just to look nice. Please don't actually do that. I know that's kind of a bad example, but just the simple black and white non-shaded PPC is what you want, because what if there's a shift inward? It's very hard to see it if you've shaded the entire inside. So just draw a curved line, because pizzas and robots have increasing opportunity costs, and always, 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 always label each good. So one side will be pizza, the other side will be robots. Doesn't really matter which side you label which, but just be consistent. So go ahead and draw all 3, the basic PPC. And then try the shifts. I recommend always doing practice shifts with a pencil, and we'll go over all of the answers when you're done. So question 1, you have new robot making technology. The question is, does that affect the ability to produce robots, the ability to produce pizzas, both or neither? Okay, that one's only going to affect robots. And can you make more robots than before or less? That will be more. So with new robot making technology, the pizza line stays where it is and the robot line should shift outward. Make sure that you definitely have an arrow showing the direction of the shift. Our next example, we have a decrease in the demand for pizza. Will that affect the ability to produce robots, the ability to produce pizzas, both or neither? This one actually is kind of a trick question in the sense that demand for pizza has nothing to do with your ability to produce pizza. Remember, production possibilities only shows how much you can produce. Because people choose not to buy pizza, that's a whole nother question. And that's not a shifter for either part of this line. Now, if people in your economy decided to buy less pizza, then you probably should decide to make more robots instead. So in this case, this is called a move along the curve. Whenever you have a move along the curve, you're going to draw two dots and you have an arrow showing which direction it moved. So in this case, you're starting off at a location where you're producing more pizzas, and its demand for pizzas go down. You're now going to produce more robots. Your ability to produce both hasn't changed at all. So the curve doesn't shift, you have a move along the curve. And last example here, mad cow disease kills 85% of cows. Does that affect our ability to produce robots, pizzas, both, neither? And if so, are we able to produce more or less? This one affects our ability to produce pizza. We use cows to make cheese, and that's important to almost all pizzas. So if we don't have as many cows, we're able to produce less pizza than before. So pizzas, just the pizza side, shifts inward. Dying cows has no effect on our ability to produce robots, so it is the same point as before. Up to this point, we've done PPCs where we focus on two different individual goods. But that's kind of more on the microeconomic side of things if you're looking at just bikes and computers. Macroeconomics, remember, we're looking at a larger scale. So when we use PPCs and macroeconomics, we do categories of goods. The two major categories that you'll usually see are consumer goods and capital goods. So we're going to be grouping goods into categories, which makes it macro. So consumer goods are goods that are used by households. These are things like food, clothing, entertainment. These goods do not contribute to future production because they tend to be disposable goods. Capital goods are the other category. If you remember from the factors of production, capital are things like tools and machinery. These goods are used to make other goods. So in terms of long-term economic growth, if a country focuses more on capital goods, they're going to produce a lot more in the future than a country that produces mostly consumer goods. It is possible to grow by producing either one, but capital goods will make the country grow a lot more and a lot faster than a country that decides to focus on consumer goods. Here you can see two countries that originally have the same PPCs. If you look in the green shaded areas, both of them can produce the same number of capital goods and consumer goods at the beginning. Panama is choosing to focus more on consumer goods. So you can see their point on the PPC is closer to consumer goods. Now, it's not producing 100% consumer goods, and that's important. If they were on the line, if they were this point here, and they're only producing consumer goods and not capital goods, then you'll have no growth whatsoever. It will actually lead to negative growth, which we'll learn about later. But the idea is where they are, they're at least producing some capital goods while mostly consumer goods. So they're going to grow, but not as far. Whereas Mexico is choosing to produce on a point on the PPC closer to capital goods, which is going to give them a lot more future growth potential because they're focusing on producing goods that produce other goods. So both countries grow, but capital goods grow more. Next, we'll practice shifting PPCs when the PPCs are for categories of goods. So you're going to go ahead and draw 4 basic PPCs. Remember, don't shade them in, just draw them in black and white. And label one side for capital goods and one side for consumer goods in each model. Once you've set up the basic PPCs, go ahead and with a pencil, draw the shifts that you think would occur from each of those scenarios, and then we'll check your answers at the end. Before I reveal the answer to question number 4, I wanted to make sure to point out that when you're doing categories of goods in a PPC, the PPC will always have increasing opportunity costs. So the curve will always be a bowed out PPC as opposed to a straight line because the categories are so broad that it will be difficult to switch between production of each of those goods. Okay, on to question number 4. Destruction of power plants leads to severe electricity shortage. So does that affect our ability to produce capital goods, consumer goods, both, neither? And if so, will we be able to produce more or less? This one, if we have severe electricity shortage, that means that plants that are producing either type of good will be able to produce less than they could before. So both lines will shift inward. So you'll draw both of them a little bit less with an arrow pointing towards the shift. Question number 5, faster computer hardware. Will that affect production of capital goods or consumer goods? That one's going to shift outward. This is a technological improvement, so you're going to be able to produce more of both types of goods. Question number 6, many workers are unemployed. Does that affect your ability to produce capital goods, consumer goods, both, or either? This one's actually a little bit tricky because while technically it does affect your ability to produce them, if those workers were working, you could be able to produce the same amount that you always could. Therefore, this is not a shift. Remember that we learned any point inside the curve shows high unemployment. So if you're trying to demonstrate on your picture that many workers are unemployed, you're going to pick any point on the PPC curve and then draw a point inside showing high unemployment and then an arrow connecting those 2 points showing that it was efficient and now it's inefficient. Remember, if those workers could work, if they got hired tomorrow, you would be back on the PPC curve. This is why it didn't shift inwards. There's a difference between people are currently unemployed and people are permanently unable to work, maybe by a plague, a war, some sort of disease that knocked out a large amount of your labor force. That would create a shift inward. High unemployment is only a move towards the inside. Question 7, significant increases in education. Do you think that'll affect the ability to produce capital goods or consumer goods, both, neither? Let's see. This affects both. Now, you learned that the quality or quantity of a resource can shift the curve. This is an example of a quality increase. If your labor force is healthier or better educated, they're able to produce more than they could beforehand. So an increase in the quality of your labor force, and in this case educating them higher, will lead you to have more overall production of both categories of goods. Take a moment and answer these 6 questions in your notes. You want to think about which point to answer the question and also be able to explain it. This is the type of thing that you might see on a future daily quiz to make sure that you understand the reasoning behind it, not just the points. Once you've done your job trying to answer it, we'll go over and check the work. You can see here I have a whole lot written on this slide, so it'll take us some time to go through it, but this is kind of a wonderful overall review of PPCs just to make sure that you understand how they work. So let's go through it point by point, and this is a wonderful study tool for you to look over at the end. Okay, 1, which points are attainable and desirable? Every point on the PPC itself, A, B, and C, are attainable because as long as we have full employment, everyone's working, it is possible to produce at any of those points. They're also desirable because it's the maximum that we can produce, and it's showing full efficiency of our resources. If you're on the curve, you're using resources efficiently. Number 2, which points are attainable but not desirable? That would be point D. Anything inside, you can make less than your maximum potential, but it's not good. It's not desirable. It shows that we're making fewer goods or services than we possibly could, and so it's going to show both inefficiency and high unemployment. 3, which points are unattainable? Is this point desirable? So point E, anything outside production possibilities, is unattainable. It is impossible at current levels of production to reach point E, but it is desirable. We would love to be able to make more of both goods, but unless something shifts on this model, unless a variable in our economy changes, point E is currently impossible to reach. It's unattainable. 4, which point will mean more production in the future? This is bringing us to those categories of capital goods and consumer goods. So if we want more production in the future, we want to be producing something that's more of a capital good than a consumer good. Within our options here, robots and pizzas, robots are the capital goods because robots can be used to produce other things. So if you decide to produce mostly robots, you're going to have the most future production, most future growth. So point A is the point on the PPC where Italy is producing more robots than any other point. 5 asks which point means more consumption now. Consumption is about consumer goods and consumer spending. In this model, pizzas are the consumer good. They are used up, they're relatively disposable, and they certainly don't produce other goods. We can't build other products using only pizzas. So point C is the point on the PPC that's focusing mostly on pizzas. It's going to lead to most consumption and the least amount of long-run growth. Okay, number 6, this is kind of the big overview with vocabulary words. So how does a PPC graphically demonstrate scarcity? It shows scarcity because there's a scarce amount of resources. We can only make 10 robots or 200 pizzas possible. There's no other potentials because there's only a limited amount of resources that we have at our disposal. The PPC shows opportunity costs because if we wanted to move from this point here to point A, you are making 65 more pizzas. There were 0 pizzas, now there's 65. So in order to gain 65 pizzas, you are losing the ability to make 1 robot. So the opportunity cost is that shift. Every other point, so here the next 65, because 130 minus 65. So in order to gain the next 65 pizzas, we're losing 2. So it increased. We had 1 that we're giving up. Now we have 2 that we're giving up. If we go on to the next point, the very last 65 pizzas, you're giving up 5 robots. So that's a pretty clear-cut example of increasing opportunity costs. In order to make some, you give up 1, then you have to give up 2, then you have to give up 5. The opportunity cost is increasing. It shows economic growth because if we shifted outwards to point E, we would know that there has been growth in the economy, that our long-term potential is higher than it was before. The PPC shows efficiency because any point on the curve, A, B, or C, is efficient. We are using all of our resources as well as we possibly can to produce the maximum amount possible. And finally, the PPC shows unemployment because any point inside the curve, in this case, point D, is showing we're not using our resources wisely and therefore we have high unemployment. So hopefully you have a good sense at the end of these notes about how to draw, label, and shift PPC models. Go ahead and pause this if you need more time filling out this sheet.